Density. Density is the mass of a substance divided by its volume. So density is, you could think of it as a measure of the heaviness. It's not the mass, but you know, sometimes you pick something up and you're like, whoa, that's a lot heavier than I expected it to be. Because we look at the size of something and we have an idea of how heavy it might be. So you pick up a box and you thought it was filled with packing peanuts, or you thought it was empty, but it's actually full of bricks. And it's like, whoa, that's a lot heavier than I thought. Different substances have different densities. And what's really important to understand is when you, like if you take a piece of wood, which has a density of about 0.8, 0.9 grams per milliliter, and you cut it in half, the mass changes and the volume changes, the density doesn't change. The density of something does not depend on its size. It's an intrinsic quality of it. Common units for density are grams per cubic centimeter or grams per milliliter, because it's mass divided by volume. So here's the density equation, and that'll be on that sheet as well. Density equals mass divided by volume. So people have different densities. How do you measure the density of a person? Okay, measuring the mass is easy. Get on a scale, measure the mass. Measuring the volume of a person is tricky. And they've come up with different, kind of estimations. They can take a measure of the fat on your arm and they can kind of estimate your body volume and stuff. But that's not really very accurate. This is the most accurate way to measure the volume of a person. You can also do this for any irregularly shaped object. So here we've got a big tank of water, and it's got markings so that we can see the volume of the water. When this girl jumps into the water, what's going to happen to the water level? It'll rise. Okay? You know this if you've ever gotten into a very full bathtub. When you get in, some of the water gets out, right? And then mom gets mad because you make a big mess in the bathroom. So she jumps in and the water level rises. The apparent increase in this water volume is equal to the volume of her body because she displaced the water. So where did the water go? Well, the water pushed up. So this is measuring volume by displacement. So let's do some examples of calculations. Well, maybe we'll just get one in. A certain mineral has a mass of 7.8 grams and a volume of 2.35 cubic centimeters. What is the density? Like temperature conversions, this is something where we have to use an equation. We need the density equation. Density equals mass divided by volume. There are two numbers in this word problem. Good idea to pull those numbers out and write them down, because when it's all jammed together in the sentences, it's a little hard to see what's going on. Now this question was kind. It says mass of. That's a big clue that this is a mass. So M equals. The other clue is the unit. Gram is a unit of mass. It doesn't measure length or volume. It only measures mass. So if you see something grams, you know that's a mass. Then it says volume of this. This is the volume. So we've got V here. So now we've identified, they've given us the mass and the volume, and we're just going to put these into the equation. 17.8 grams divided by the volume, 2.35 cubic centimeters. Pretty straightforward on the calculator, as long as you remember to turn it on. 17.8 divided by 2.35. My calculator is showing me a big old mess. How many significant figures should this answer have? It should have 3. So what I'm going to do, instead of writing down all of them, I'm just going to There's 3. I'm going to write down maybe 3 more, just so that I'll be safe when I round. And what are the units? Do any of these units cancel out? Grams and cubic centimeters, are those the same? They're not the same. Nothing cancels out, and so we just carry those guys along. Grams per cubic centimeter. Now I've identified that we need to round to 3. This is 3 sig figs, this is 3 sig figs. So I'm going to keep 757, I'm going to keep to this place. I'm going to look at the next digit to see if I need to round up or down. So the answer here is 7.57 grams per cubic centimeter. Any questions? So example 2. Another density problem. What is the mass of a 49.6 milliliter sample of a liquid which has a density of 0.85 grams per milliliter? So we read the word problem all the way through, and then we figure out, okay, what are the numbers they're giving us? So we've got this guy right here, and we've got this guy down here. So this is another of those situations where we've got more than one number. So let's write them both down. 49.6 milliliters, 0.85 grams per milliliter. Write your fractions vertically so that they jump out at you as being fractions. When you write them horizontally with a slash, they sometimes don't really look like fractions to you. We can guess pretty accurately, just looking at the units, which number we start with and which one we have to work in as a conversion factor. Which one do we start with? The 49 or the 0.85? We want to start with the 49 because that doesn't look like a conversion factor, does it? It can't be a conversion factor. It's just a single unit. But this guy is relating grams and milliliters. So this is a density problem, and yes, you can solve a density problem using the equation. You can do that. If you are good with algebra, you go right ahead and do that. You'll take the density equation, D equals M over V, you'll rearrange it and plug the numbers in and solve it. And if you're good with that, you don't need me to show you how to do that. Most of the students in here are not real on good terms with algebra, right? You're like, algebra is not my friend. So we can do a lot of these things using dimensional analysis. And I do want dimensional analysis to be your friend. We can do this problem using dimensional analysis. So that's how we're going to approach it. So we're starting with the milliliters. And what is the question? The question is, what is the mass? See that? What is the mass? Okay, so there's 2 different units showing up here. We've got grams and we've got milliliters. Which of those is a unit of mass? It's grams. Now where was I? My computer died. I'm telling the YouTube people. My computer died and I paused, and now I'm trying to remember what on earth I was doing. Yeah, good. We told stories. Let's see. We're going from milliliters to grams. We can go directly from milliliters to grams because we have this conversion factor over here, this relationship. We have something that has grams and milliliters together. Grams per milliliter. So we can just do this in one step. So we're just going to start then. We've got a little short path, milliliters to grams. So we're going to start out 49.6 milliliters. And we got one fraction. And on the top is milliliters to grams. The path tells us what to put on the top. Then we put the units on the bottom so that they cancel out and go away like we want them to. So the milliliters cancel out. Get all the units in, and then deal with the numbers. So over here we have the density. This is 0.85 grams for every 1 milliliter. So 0.85 goes with the gram. Important to keep the numbers and their units together. If you want a number on the bottom, it'll be the number 1. Then we just get out our calculators. 49.6 times 0.85 equals. Calculator says 42.16. And the unit there will be gram. Then we need to identify the number of significant figures and round it. So here we've got 49.6. How many sig figs there? 3. And in 0.85? 2. That leading 0 doesn't count. So 2. 2 is smaller than 3, so we're going to round this off to 2 significant figures, 42 grams. And then a nice box. Any questions? What?
Let's go with the lowest sig fig.
For multiplying and dividing, which is mostly what we'll be doing, you look at all the numbers that were in your equation, and whichever one has the fewest number of significant figures, that's how many your answer will have. Any other questions? Okay, another exercise. If an object has a mass of 243.8 grams and occupies a volume of 0.125 liters, what is the density of this object in grams per cubic centimeter? Okay, so we read the problem, we pick out the numbers. Occasionally they put in extra numbers, but not too much in this class. So we got these two guys. We've got 243.8 grams, and we've got 0.125 liters. Does either one of those look like a conversion factor? No. There's nothing per, right? There's no grams per cubic centimeters or miles per hour or anything like that. So, okay, well, there's the numbers. What's it asking us to find? The density. Oh, there's an equation for density, right? I'm just kind of thinking out loud like I think a student might think. So density equals mass divided by volume. Do those numbers that I was given look like they might be a mass and a volume? Yeah, they do. So let's make sure we correctly identify them. 243.8 grams, that's the mass, and liters is the volume. So this is not a dimensional analysis problem at this point. We're just going to put these units in to our equation, put the numbers into the equation. The mass goes on top, 243.8 grams, and on the bottom we've got 0.125 liters. And we use our calculator. We got 243.8 divided by 0.125 equals, and this is telling us 1,950.4. What are the units on that number? Nothing canceled out, right? So it's still those same 2 units we had, grams per liter. Is that the correct answer? No. And look, D, 1950. Hey, we got 1950. Great, we're done. That's right. No. In grams per cubic centimeter. Oh, shoot. Our unit's wrong. Now, there's 2 things you could do. You could go back and change the liters to cubic centimeters and put it in the equation again. Or you could just take this number that we've got and just convert the units. So I'm going to do the second option. So we've got 1950.4 grams per liter. We want that liter to be cubic centimeters. Do you know the relationship between liters and cubic centimeters? Well, centi means 10 to the negative 2. We know liters to milliliters, right? And then there's this often forgotten relationship that 1 milliliter is exactly the same as 1 cubic centimeter. And that'll trip you up a lot. And I'm sorry, but I can't change it. The rest of the world wants to do it this way. A milliliter is exactly the same as a cubic centimeter. So really what we're trying to get is grams per milliliter, right? Can we convert liters to milliliters? Oh yeah. So let's put a conversion factor in here. Now this is going to be a little bit different because the liters are on the bottom. And where do we want the milliliters and eventually the cubic centimeters to be? On the bottom. So we're kind of doing this upside down. I'm going to put milliliters here and liters up there because I want the liters to cancel out. Is that too confusing? If you don't like it this way, then do it the other way. Take the volume and convert it to the right unit first and then stick it in. But some of you might like this. What's the relationship between milliliters and liters? Milli means 10 to the minus 3. So we're going to put what it means on one side and we've got the prefix on the other side. Then over here, I want milliliters to cancel out and I want to get centimeters cubed down there, and that's just 1 to 1. Do you absolutely have to write that in there? No, you don't. It's okay to convert to milliliters and then just change the name, but I don't want to disturb people too much, more than I have to. So this is going to end up being 1.9504 grams per cubic centimeter. So which is the correct answer? A, B, C, or D? It's B.
So, like, whatever unit of measurement you want, you put that on the top of the fraction thing?
I don't know what happened. This is the... Yay!
Well,
I don't know how I make it come back. It's always just like, wow, okay. I'm going to answer a question. Just frustrated with my technology here. So, you have to pay attention to where the unit needs to be. I did it this way to illustrate that we can convert units that are on the bottom as well. So if we're needing to convert a unit that's on the bottom, then all of these guys are going to be upside down of what we would have done if we were converting a unit on the top. So I hope that didn't confuse anybody, but any other questions? Would you like to see it the other way? Changing the milliliters, the liters to cubic centimeters first? Okay, we can do that. So, density is mass over volume, and we figured out that the volume is in the wrong units. So we can take the 0.125 liters, so we need to get that into cubic centimeters. So maybe off to the side, we're going to write our little path. We want to get to cubic centimeters, but we're going to have to go through milliliters first. So we'll have 2 steps here. And now liters to milliliters to cubic centimeters. Liters to milliliters to cubic centimeters. And the previous unit goes on the bottom, and the previous unit goes on the bottom. Get all the units to work out, stick in the numbers. A cubic centimeter and a milliliter are exactly the same thing. It's a 1-to-1. Cubic centimeter is a different name for milliliter. That's all it is. And the milli means 10 to the minus third. So on the other side, we're going to write what it means. On the top, we have milli. On the bottom, we have what it means. They don't go together. So that's 1 times 10 to the minus third. So you do this on your calculator, and you come up with the volume being 125 milliliters. I'm sorry, cubic centimeters. So that's an intermediate answer, and we're going to put that up here, 125 cubic centimeters and 243.8 grams. And we're going to divide that, and we're going to get 1.9504 grams per cubic centimeters. The answer still comes out to be B. B, the answer has 3 significant figures because our initial number here, 0.125, had 3 significant figures. So that's why it is rounded. Any questions? Yes?
You do it without scientific conditioning. Just using the very small
You mean converting the units?
converting sort of
Yeah, there are other ways.
or
When you're familiar with the metric system, you can look at liters and you say, oh, I just need to move the decimal point over 3 places. And you can just convert it in your head. And if you can do that, that is awesome. And do that. But I know that a lot of the class isn't there yet. So, and sometimes like with centimeters and meters, the way I'm doing it is I'm showing you 1 centimeter equals 10 to the minus 2 meters. It is also true that there are 100 centimeters in a meter, and that is a very valid conversion factor, but it doesn't follow the pattern I'm teaching you, and I don't want to confuse people. Is that?
going to later talk about stoichiometry and sort of follows the same.
Yeah. So what we're learning here is the pattern of dimensional analysis, a technique, and we can apply it to all kinds of different things. And what's wonderful about it is if you learn the steps, it applies to lots of things. What can be a little frustrating is that there is more than one correct way to do many of these things. And so that bothers people. You know, with the density, you put the numbers into the equation. Density is mass over volume. With the unit temperature conversions, you use the equation. There's one way to do it. But converting these units back and forth, there's more than one way to do it. And so I'm going to try to be consistent and just show you the one way. But I'll tell you, there are other ways, and if those make sense to you and you get the right answer, you go for it. Any other questions? Yay, end of chapter.